In this tutorial, we're going to look at the new custom lattice capability within Sulis Lattice. And first of all, I've imported a model into my build environment, and I'm going to click on this model and add a strut lattice component to this model. So I'm going to click on the strut lattice button, and we can see in the strut lattice panel that there is now an option beneath the built-in unit cells to add custom struts, a custom unit cell. So what we're going to do is click on the select unit cell button, and this gives us another tab to either select a unit cell, but we don't have any saved unit cells at the moment. So first thing we need to do is add a unit cell to our list of custom unit cells. So I click the add button, and I'm gonna then now create a custom unit cell. So first thing I'm going to want to do is give this unit cell a name. So the unit cell I want to create is called the rhombic dodecahedron. So I'm gonna just call it rhombic. And then we have two input fields here. One is for the vertices of the unit cell, and one is for the connectivity matrix for the struts. So if I navigate to this window here, this is the unit cell that I want to create. Each of the dots that you can see now in green represent the vertexes of this unit cell. And each of these will have an X, Y, and Z coordinate attached with them. So let's, for example, consider this node, this vertex here, to be 0.000 in space. And then this will be my next coordinate, and this might have 0.25, 0.25, 0.25, for example. I then need to then input each of the coordinates of my new lattice into that box. So I have a list of coordinates here in this text file, representing each of the vertices of my custom unit cell lattice. So I'm going to select all of these and copy and paste them into my box here. Now in this case, we are space separated variables. So X and then a space for my Y coordinate, then a space for my Z coordinate. And then we start a new line, and then the X coordinate, the Y coordinate, and the Z coordinate. You can also have comma separated variables. So if instead I had commas between my X, Y, and Z, that would also be an acceptable way to input data into this field. Next, we have the strut connectivities. So each of these vertices will have an index attached to it. So this is my 0. If I go back to this, this will be my 0 index. This will be my 1 index. This will be my 2 index. This will be my 3 index. This will be my 4th index, for example. Then the connectivities we see, if I go back to this unit cell, what we see is that this strut, if this was my coordinate 0, 0, 0, and this was my coordinate 0.25, 0.25, 0.25, these then need to correspond with the indices inside of my vertices list. So this one might be 0 and this one might be 1. And then what we do is we then create a list of connectivities between the vertices in the list. And then we copy and paste these into the strut column. To explain this another way, we can bring up the connectivity matrix and the list of node connectivities together. So here we can see the coordinate 0, 0, 0 being our index 0. And our next node, or our next vertex, has a coordinate 0.25 minus 0.25, 0.25. And then the first strut in our unit cell will connect these 2 points together. So we have index 0 here and index 1. The next strut in our lattice connects coordinate vertex 1 with coordinate vertex 2. So this corresponds to this coordinate here, and then this coordinate. So there'll be then a strut connected between these two variables, and so on and so forth as we go down and create every single strut in our lattice. Again, these can be comma separated or space separated, with the new strut being on each individual line. So each of these corresponds to a connectivity for one strut in the lattice structure. Once we're happy with the vertices and the struts, we can save this lattice. And then we click on the Manage button, and then we can select the unit cell that we've just created. Then we can then have the exact same commands that we initially did. So we have the strut thickness, the node inflation factor, and the number of cells in each of the axes. And then you can see that if we press generate now, we have a new type of strut that we can then use to input into our shapes and export for 3D printing.